host, Chad Miller. Today I've got a couple guys here with me, but we'll get to those introductions first. What we want to talk about today is a little bit about what we've got coming up. Got some new engines going around, are going to be released to the public. And we've kind of got this thing coming up next week. It's called PowerGen 2024. Down in the Big Easy, we're making some big preparations for that. You can't really talk engines without a couple of smart guys in the room. So please, viewers, make welcome Mr. Jason Mewa, Mr. Trevor Hallowell. Guys, let's take a second to introduce yourselves, what your role is with the company, and what we're here to do today.
Sure. My name is Jason Mewa. I'm the Director of Engine Development here at Mesa. And so my responsibility is to oversee the development of our engine line, everything from the design, calibration, certification, and deployment. So,
awesome. Jason, how about yourself? Trevor, how about yourself?
Yes, I'm Trevor Hallowell. I'm the lead design engineer on engine development. So kind of me and my team, we handle the CAD packaging of these engines, kind of the design aspect on the computer side. So
cool. Okay, so let's dive right in real quick. So earlier last year, Mesa had some pretty big news happen at the Con Expo there in Las Vegas. Something about an agreement with HDI. Why don't you tell us a little bit about that?
Yeah, so super excited about the agreement. Great opportunity for two great companies to come together. HDI, who provides us with the long blocking engines, and then Mesa, who's going to be the global distributor of these engines. So we're focused on dual fuel engines, natural gas and propane, and the agreement allows us to import these long blocks, complete the engines, and then certify them with the EPA and sell them to customers and use them in generators.
Man, that's a lot of information, and the big one there being the EPA certification. We'll get to that here in a second. Yeah. Trevor, what's responsible with Mesa? What do we do to these engines that made them different, and kind of what role do we play in these enhancements?
Yeah, so I mean, really, we're getting kind of just base long blocks from HDI coming out of South Korea, and when they arrive here, we're doing everything from speccing out turbos, CCMs, throttles, all that fun stuff, and getting it put on the engines, and then going through all the testing and certification on them. So
okay, well, we're talking engines plural. How many are we currently looking at right now? Let's go through the models real quick.
Okay, well, we'll start with the GV22PU. That's the most similar to the previous version of the engine. Mm-hmm. Same 22-liter base engine with a few upgrades and improvements. We can talk about those here in a bit.
Yeah.
But let's start with the GV22PU. And then we also have a new engine line coming out. That's the GX engine line. We're super excited about the GX engine line.
Heard a lot about it.
Yeah, so the GX engines, we're going to have another 22-liter, but it's going to be a little bit more powerful. We're going to have a 15-liter and a 12-liter. And then a little bit later, we're going to be doing the 8-liter, both naturally aspirated and turbocharged.
Cool.
So we'll have a whole line of engines available.
So we're looking at more efficient, more power, obviously better runtime for the end user at the end of the day. See a little pattern develop here. So I understand you're talking a little bit second ago, Trevor, about the throttle body. What's the situation with that? Why the changes were necessary, and what did we do to make things better?
Yeah, so one of the first things we did when we got the engines is we kind of look back at what we saw for service call outs in the past. Throttles were a big one. Saw quite a few issues with them, a lot of service call outs for our field techs. So we've transitioned to a new industrial throttle, a little more robust.
Really?
Going to be just a little bit beefier and hardier than what we've seen in the past. So.
Gotcha. So again, less chances for something to go wrong, better performance out in the field, less downtime for the end user.
Exactly.
That's awesome. So tell me a little bit about the intake manifold. I was down in Casper last week taking a look at some things, and some items popped out onto the engine to me. They seemed a little bit different. What changes were made there at the intake?
Yep. So I mean, the new intake manifolds on the PU, they're kind of better designed for a more even distribution across the cylinders. And Jason's got a little bit more background in the diesel world, and he can kind of explain what that difference is. So
the base engine design was based on a diesel variant, and then we're gasifying and making it a gas engine to run on propane and natural gas. Mm-hmm. Well, the design for a diesel intake manifold is a little bit different than what you expect out of a pre-mixed natural gas engine.
Okay.
When we have a pre-mixed natural gas engine, the sparking guide, we need to make sure that every cylinder, the balance of flow and charge that's going to every cylinder is a lot more carefully designed, so that way it's much more even. That way that first cylinder, he's not eating too much, and that last cylinder's not starving to death.
Right.
So trying to make sure everybody gets their fill of fuel and air in an even way, so that way we have a much more consistent running engine. Diesel engines, it's not that big of a deal because all they're pushing is mostly air.
Gotcha. So consistency is the key when you're talking with a natural gas engine.
Yep.
Makes sense. So I heard some information about the NOx sensors that were on the previous engine models and how we've kind of moved them around, the purpose of them, why we did what we did. Can we talk a little bit about the NOx sensors real quick?
Sure. Well, maybe we'll start with a little bit about what the NOx sensors you're trying to do.
Perfect.
Most people know like knock bad. And there's
Yeah.
engine calibration to try to take care of it, make sure the engine's not getting a knock. But if you take a step back to kind of some of the basics of what the knock sensor is doing, it's basically like a microphone. It's an accelerometer that's listening to the engine, listening for that knock.
Wow.
And the knock is kind of an abnormal combustion, so it's going to have a pretty high frequency ringing. The way I like to think about it is if you ever been in the shop and you drop a wrench and you hear that ding, 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 ding.
Yep.
Yeah, so that's basically what the knock sensor is looking for. So when we're looking at the calibration side of things, we want to make sure we place those microphones in good locations to where we can listen to all of the cylinders. On the previous version of the engine, there were some that were down on the block and there were some that were on the exhaust manifold. Well, just like microphones, the closer you put it to the source, the better chance you're going to be able to hear and understand it as opposed to all the background noise.
Right.
So when we designed the engine, it was a focus on trying to make sure that we put the knock sensors close to the combustion so they're now mounted on the cylinder head, and that gives us better data to work with so we can triangulate exactly where the knock is coming from. And our algorithm will actually detect individual cylinders and make individual cylinder adjustments for that knock.
On the fly.
On the fly.
That's incredible. That does make sense. The further you are away from it, the more chance for misinterpretation, wrong coding, anything else, you send it to the wrong cylinder that needs it the most. Oh, makes sense. So let's talk a little bit about the new GX. That one's going to be coming out here in the near future. We will have all these engines on display at PowerGen this year. Booth 2108, I believe is what it is.
I think that's it, man.
Looking forward to it.
Now.
Marketing team has done a fantastic job at setting this booth up. So you'll be able to come into the booth, visit with both Jason, myself, and Trevor as well. Kind of ask some questions, touch it, feel them, take a look at them, have anything that you may spawn up in your head. We'll have the answers for you there. But we'll also be showcasing the new GX line. So let's differentiate the two models between the 22 PU and the GX line. What does that look like?
Yeah, so the GX engine line, we've transitioned to a 4-valve overhead instead of a 2-valve overhead. One of the big benefits of that is it leads to an increase in strength of the head, which means increased cylinder pressure, which means more power.
Because that was a failing point in some of the other previous engine lines, right?
Yep.
Okay.
Valve bridge cracking and stuff like that. So we worked with HDI, and HDI did a lot of the design work on that to try to make a stronger head.
Right.
So same footprint, more power.
Yep.
Everybody likes that line, right?
Yeah. That's the best. Most bang for the buck possible is always a good scenario, right? So what are some of the applications for these engines? You hear everybody at home's hearing us talk about, hey, we do engines, we're building all these different things. What are they designed for? What are some prime applications for them and things that the customer can use at the end?
Yeah, good question. So the engine is designed to be a generator engine. We're all about making power and make sure that when you get home at the end of the day, you can turn your lights on, or if you're at a site, that we're maintaining power for that facility at all times.
Okay.
So the engines are designed for emergency standby use. If you need a backup generator, they're intended for prime power applications, both in commercial and industrial applications, but also in other places where you might have oil and gas applications and be using wellhead gas. So we try to design the engine so it's going to go in a lot of different applications and cover a lot of different bases. We also have a 50 hertz and a 60 hertz version of the engine. So most of the folks here, we're all on 60 hertz power,
right?
But we're looking globally. There's a couple of markets out there that have 50 hertz. So when we're doing all of the testing and development, we have both the 50 hertz and the 60 hertz.
Well, you mentioned emergency power. I know most of the country from pretty much the North Dakotas all the way down to Central Texas is kind of gripped in a nice little Arctic blast that we've had in the last few days. So it all makes sense. I mean, in situations like that, emergency backup power is something that would be an ideal match for this engine line that we've got coming out. That's pretty neat. So let's talk about durability, right? So my history with the company, I've done a lot of the rental side for the oil field application. So I'm pretty familiar with the operating environments down there, whether it be in West Texas in the heat, South Texas, heat, humidity, a lot of dust. Talk to me a little bit about the durability of these things and what we're doing ahead of time to make sure that there's the expectation and then there's the Mesa standard that we all hold ourselves accountable to.
Yeah, I mean, we do quite a bit of durability testing as we're running through the certification process with these engines. We've got a couple different tests that we run. For example, ones we run it full load, max power for 100 hours straight.
Wow.
Basically just letting it eat and letting it get hot. And we instrument heads, pistons, liners, thermocouples, monitoring temperatures in the cylinders and everything else. And then one of the big benefits about Mesa being a generator company is kind of one of the first field trial durability tests that we do is in one of our own units. So when we finish up these engines, we throw them in one of our units, get it out in the field, and start getting hours on them.
Now, I'm glad you say that because anybody that's buying a new engine, investing that amount of money into their fleet, they're going to want to know that they're not the guinea pig, right? And we take pride here. We put them through the strenuous tests. 50 million something run hours that we've got right now on the fleet. And so if we thought of it, we've put the engine through the ringer. If there's very few instances that would rise where it's something we hadn't thought of ahead of time to try to make sure that we weren't being caught off guard, right? So, and you've also had another engine down at Southwest Research recently doing some cycling engines or cycling testing down there.
So there's the high temperature test where we're really trying to maximize and check that our cooling kit's working good, the engine's surviving. But these engines also flip on and off a whole bunch of times. So one of the tests we have going on right now is a durability test, is thermal cycle test, where we take it from kind of a cool idle condition and we take it up to full power, let everything heat up, and then we cycle back and forth around 4,000 times.
That's not easy.
We're just putting her through the ringer, just turning it on and off as quick as we can. And that's a pretty long durability test. At the completion of that test, one, we're going to make sure we can still make power. We're still hitting all the targets for performance. And then we'll completely disassemble the engine, inspect all the internal parts just to make sure we're hitting the mark on all of our durability targets.
See, I don't think a lot of people equate that mentally in their minds very much as far as what an engine's designed to do. Coming off the starting blocks, I picture a drag race car. You go from an idle to just wide open throttle to shut the engine off. Guys go in and tear it down. We're not getting to do that part. This is straight idle, straight 100%, back to idle, as many repetitions as you're saying. That's an engine's worst nightmare in my book. That's awesome, man. So let's think about support rise. So once a customer were to buy one of these engines or generator for that matter, what kind of support could the end user expect from Mesa?
Yeah, certainly. So that's one of the things that Mesa really prides itself is customer service and taking care of the customer. So we've been on the other end where we bought an engine and we didn't have exactly the customer service we were hoping for. So we're taking that experience and we're trying to preemptively prepare ourselves to make sure that we have all the right documentation, all the right manuals, and there's a person on the other end of the phone. When you call us, there's somebody else to answer and help address a lot of those problems.
Okay. Well, real quick, and not to kind of catch you off guard here, but we talked a little bit about the EPA certification. From what I understand, it's not an easy process, right? Let's face it. But you guys got it done. Tell me a little bit about that process, what you had to go through to get it, and what that means for Mesa moving forward.
Oh, you want me to take this one?
Yeah.
Yeah. Okay. So it's a lot of different testing. So one thing is you have to specify all the components and make sure that they're production intent. So speccing out new turbochargers, new catalysts, new all sensors and actuators. We've got to go through all the development process to make sure we have good transient control, we have good steady state control, that we're meeting emissions. We do all that in the development process before we go into the certification test cell.
Gotcha.
The certification test cell, you've got to go in there and you've got to prove that EPA may have a limit, but one of the things the EPA wants to see is like, well, that's a new engine. What happens over time? And so there's factors that we include in that testing to where when we're actually in the certification test cell, we're taking into account the lifetime of the engine and the lifetime of the after treatment. And we're actually testing to a much, much lower standard.
Gotcha.
So the target for the certification test cell is way, way below what the EPA requires, just so we can make sure that after thousands of hours in the field, we're still within compliance.
Okay.
So lots of testing, basically.
Fun stuff. Trevor, touch base on 2024. So far, we're a little over halfway through January, right?
Yep.
Still got 11 and a half months left of the year, but it's going to be busy. And if I haven't said it already, these guys stay busy pretty much 24/7, whether they're in this office or out. So I certainly appreciate y'all taking the time out of your days to talk a little bit. So tell me about 2024. What can we expect from Mesa?
Yeah, I mean, we actually just got our GV22PU certification engine back. It actually just landed back here at our Loveland facility yesterday.
Saw that.
And then just kind of rolling straight into that GX line. I mean, GX22 is up first. We'll be rolling into the certification cell here in the coming months. And then just kind of rolling down that line that Jason went through, GX22 and then GX12, and then the GX15 right after it. So it's definitely going to be a busy year, but it's going to be a lot of fun.
So with busy year and a lot of sales, that equates to growth, right?
Yep.
We've all been kind of preparing ourselves for that coming up ahead of time. So tell me a little bit about your teams that you have in place. Jason, we'll start with you. Let me know exactly like what this has looked like in the design process, the hours, the man hours that Trevor and the team have put into it.
Yep.
Let's bring this thing from cradle to grave. What was it like developing this thing?
Oh, well, I mean, it's a fair bit of work, but we got a great team here in Mesa, a lot of people that are really focused on what our goals are. So, we have a couple of teams that all work together. There's the design engineers that Trevor leads that are trying to make sure that all the components fit together and we have a good design that thinks, 6 months into the future about serviceability and how we put things together and take them apart to make sure it's the end user can still do all those maintenance items. So once the design team has specified all the parts, we kind of hand it off to the shop. They build the components, and then we have, of course, the calibration team, and then we got a team of calibration engineers that are sitting in front of that engine, again, countless hours, programming that ECM, the brains of the engine. They've got to populate it with knowledge. So they're doing a lot of testing on a lot of different conditions, just trying to make sure that the air-fuel ratio control is working, the throttle control is working, that the catalyst is happy with the engine, and the engine's happy with the catalyst. So
because those have to work in conjunction with each other, everything goes right.
You want to keep that low emissions level, you got to make sure everything's singing and dancing together. So a bunch of work, but we got a good group of guys, and we've also got a team up in Casper that's focused on manufacturing, making sure that, as we're scaling up from building 10s, 20s, up to 100 engines, that everything's in place. We have the right supply chain in place, and then we're stocking the right parts on the shelf.
It's awesome stuff. So one thing that I'm sure a lot of the viewers may be asking right now is talk maintenance to us real quick about these engines. What can they expect life cycle wise in between service intervals and things of that nature?
Yeah. So, me keep talking. You want to keep talking?
Yeah. I mean, it's the service schedule. We're kind of seeing similar to what we've seen in the past. There's a lot of items that we're getting more life out of. I mean, throttles are a big one. Right. We're going to see a lot more service, or a longer service interval on throttles. We've got a new integrated mixer that's going to have a longer service life as well.
Okay.
So we're kind of just trying to target more robust, longer time between services and less downtime.
What is the standard right now that we hold ourselves accountable?
Well, for the EPA, we're targeting around 500 to 750 hours between services.
Oh, wow.
Just depending on the application, right? Obviously, if you're in an emergency standby application, you're only going to run the engine 200 hours a year. Well, you're probably not going to do as much service.
Right.
On the prime side of things, we have a little bit different service schedule as far as like when you want to get out there and change the oil, when you want to change the spark plugs, what other things you want to check as far as fittings, air filters, all that type of stuff.
Okay.
But part of the engine manual that we have kind of lays all that stuff as far as the service schedule. The great benefit from Mesa is we do the service. We have thousands of these generators and
knowledge.
We've got a ton of knowledge in our maintenance department about the guys that are actually out there wrenching on the engines, and man, they love giving engineers feedback. So
no, that was something
great.
That was something I posted on LinkedIn not too long ago promoting the power gen. Is you really got to come see what happens when experience meets knowledge and integration and being able to do what we need to do with these things. So talk life expectancy with me of the engine itself. What can a customer tend to kind of plan on seeing out of their engine?
Great question. I have a tendency to talk.
No,
but
Trevor will let you take this one.
No, we're seeing 40,000 hours before a full overhaul.
Right.
Wow.
Yeah.
So I mean, we're targeting about 40,000 hours before you need a full overhaul, rebuild of the engine. I think we do a top end at 20,000.
Yep.
So it's one of those that you're going to see a ton of life out of it before you got to do any of the major overhauls.
With good maintenance.
Yeah.
With good maintenance, take care of everything there.
Yeah.
All right. Well, let's get to some of the questions that we have. Some of the viewers that are sent in real quick. Let's see. Where are these things going to be manufactured? Can you tell us a little bit about the process that goes on in Casper?
Yeah. So that's going to be manufactured up in Casper. So kind of our workflow is all the first run prototypes and certifications are going to come out of Loveland.
Okay.
And then they go up to Casper for production. Basically, just run it down the line, basically like an assembly line. That's one of the big things that we try to target in the design, is how easy it is to actually build them.
Oh, wow.
Make sure that we're being efficient with the parts that we're putting on it, that it's easy for the guys up there. It's not time consuming, it's efficient, and it can just run down the line.
Yeah. One other differentiating factor between some of the other engine you might get in the Mesa engine is we got a lot of feedback from our end users.
Right.
And one of the challenges they said was, man, we can't get these things tested before we get them in our hands. So as part of our process, we did install an end-of-line test dyno in Casper. So when we roll an engine down the line, we're going to make sure that it makes power and that it runs and that all the sensors are working and talking before we put it in a customer's hand. Just give ourselves that check.
So it's not right off the assembly line and right onto a truck or right into a gym. We're going to put these things through a test.
We're at least going to put them in there and make sure they pull power, which is something that we had requested from some of our suppliers in the past, and we didn't quite get what we were looking for. So when we go to assemble our engines, we're going to do it the Mesa way with that high high standard. So.
Well, that's good that you say that, because fortunately for Mesa, we have some pretty good partners in the field, especially on our oil and gas side. We've got so much feedback from those guys in the field on a daily basis. There's really an open lines of communication at all times. Any changes that we may be suggested, hey, is there any way you guys can do this? All that stuff gets chalkboard at some point, and we kind of run through that's y'all's job is figure out, can we do this, can we not, right? So help me a little bit about fuel. Another question come in a little bit about what's the prime range, what kind of fuels this thing run off of, what's its sweet spot? Let's touch base on fuel.
Sure. So as part of it, when we certify the engines, we of course do it on pipeline natural gas, and we do it on propane.
Mm-hmm.
We also test it to over a wider range of fuels because we expect these things to see wellhead gas. So we test from 700 BTU up to 1800 BTU and just verify that the emissions are in control and understand what the engine's going to be doing in that. So just because in our personal experience, we put these things out there, and some of the first engines we put out, they weren't running real well on pipeline gas. So we included that in our development process to make sure that the engine's going to make power when we put on wellhead gas.
Got it. So do you think all this was kind of, brought about with the agreement with HDI? Is it first impressions as they come here and they take a look at us and say, hey, we want you guys to be the ones that we partner up with? What do you think? I mean, I know the answer to this because we're all Mesa proud, but what do you think was the biggest factor for HDI wanting to enter an agreement with Mesa Solutions?
Well, I think part of it was they had an opportunity to see the Mesa culture, and they saw our operations. I mean, when you see the number of generators that we have out in the field, when you see the number of run hours we have on our fleet, they see that, man, these guys probably have more durability hours on the engine than they do.
Right.
So that's what I mentioned before. It was a great opportunity to bring two companies that are great, bring them together, pull on each other's experience, have really great communication and stuff like that. So far, it's been a wonderful partnership. So
that's fantastic. And I know they'll be visiting the booth next week in New Orleans down at the Big Easy. I'm going to be visiting with those guys and moving forward. Anything else you guys want to touch on the GX line or the GV22PE before we sign off for the day?
I think we pretty much covered it. It's going to be an exciting year. Got a lot of new engines coming out.
Okay.
Yeah.
And then I guess if there's any other questions that viewers may have, we are going to be making ourselves available. Please feel free to reach out at any time. Check out our website. Go to the website and take a look at what we've got going. We're going to be booth 2108. Hats off to the marketing team here at Mesa. They've done a fantastic job. They've been such great people to work with and help us make it look. I'm excited about what this is going to look like. It's going to be a lot of foot traffic coming through, and we're going to be doing a lot of other things as well. I think we're going to have we'll be over at the Altera booth for a couple hours, 3 to 5 on the 23rd. Is that correct? Or they're going to be coming to our booth?
Yeah.
Sweet. So Altera Power System be there for us to kind of a visit with as well. Guys, I know you're busy. I feel bad pulling you away from your jobs and doing this stuff, but certainly appreciate your time. Jason, thank you for everything and all your knowledge. Trevor, y'all's hard work of your team. If y'all have anything that you need from us, please let us know. Folks, thanks for tuning in. If you have any questions, please do not hesitate to reach out.